channel STL Academy, educating India in a lucid way. I am myself Amit and I am back with a lecture series on UPPSC Assistant Engineer Examination. And in this series, I am going to solve the last year questions which have come in the examination for Assistant Engineer in UP. Okay, so these questions are very much important for your exam. So guys, do watch it from beginning till the end, and I've covered up each and every question in detail analysis. And I hope you will like this lecture. And if you have not subscribed my channel yet, so please do go and click on the subscribe button, and please subscribe this channel for the latest updates available from my channel. Okay, so guys, let's start the video now. So in this lecture, I've already told you that we will be starting structural analysis through objective questions for UPPSC Assistant Engineer 2019. I have covered up 10 questions in this lecture which have come in last year examination. Okay, this is a series 1 and we will be forwarding the series to various other parts. So first, this is series first, and this is the first question for series first. A simply supported beam of span L length and a flexural rigidity EI carries a unit point load at its center. Okay, so suppose this is a simply supported beam and it carries a point load at its center. It has length L and flexural rigidity is EI. The strain energy in the beam due to bending is, we have to find out the strain energy in this beam. Okay, so what will be the strain energy in this beam? Let's see. Suppose this is a beam of point load P acting over this beam and simply supported of length L and flexibility EI. And strain and energy, we know the formula for strain energy is half into P into delta. This P is the force, or you can say at load, which is acting on this beam, and this delta is the deflection which is produced by this load. Okay, so but we know that due to with this point load, this beam will deflect like this. Okay, and this deflection will be how much? This will be taken as delta, and this will be PL cube upon 48 EI. This is the formula for the deflection. So here I have already mentioned it. For simply supported beam, delta is equal to PL cube upon 48 EI. So if we replace this delta in the above equation, we get half of P into delta. We can replace this in this equation. So then we will get delta. We can replace PL cube upon 48 EI. So after solving it, we get P square into L cube upon 2 into 48, that is 96 EI. So P, if we take P as 1 kilonewton, then the answer will be L1 into L cube upon 96 EI. So the complete answer will be L cube upon 96 EI. Okay guys, so this is the answer for this, and the answer for this equation will be L cube upon 96 EI is the right answer. Okay, so let's move on to the next question, next slide. And here I have all mentioned you each and every beam. You can see here what will be the deflection and what will be the maximum slope for the each beam. Suppose this is the first, let's take as the first beam. This is the cantilever beam in which moment M is acting. So when this kind of beam is given, you will take slope as M minus ML upon EI, and Y will be equal to minus ML square upon 2 EI. Okay. Now if a point load is acting on a cantilever beam, then slope will be PL square upon 2 EI, and maximum deflection will be PL cube upon 3 EI. So I've given you all those tables. This table is very much important for your examination point of view. They directly ask you these formulas, or they will give you some question on this based on this formula. So don't forget this value. These are very important. Take the screenshot for this and just learn it up and mug it up. Okay, then comes the second question. An overhang beam of uniform flexural rigidity EI is loaded as shown in the figure. Okay, and the deflection at the free end. We have to find out the deflection at free end. This is the free end. So यहाँ पर हमको deflection find out करना है. Okay. So how we will find out this? Let's take it. This is a beam which was given and the load was acting at C, AB. This beam is length L and this is distance is L by 2. So if these are the supports. So if we take this reaction as RA and this reaction as RB. So we can find these RA and RB using this equation, moment of equilibrium. First is moment of MA barabar 0. If we take moment at hinge is equal to 0, then this RB into L, this will give you anti-clockwise moment. Okay, this moment will rotate, this RB will rotate beam like this, so it will give you anti-clockwise, so it has taken minus sign. Then plus W will, this will rotate, this W will acting downwards, so it will rotate beam like this in clockwise direction. If we take from here, it will rotate like this. Okay, so we have solved. After solving, we get RB is also CW by 2, and if we take sum of vertical forces in y direction is equal to 0, then RA plus RB is equal to W load acting, and then RA will be equal to W minus 3W by 2. 3W from, we can here take it from here, so W minus 3W by 2. So RA value will be minus W upon 2. So the total strain energy stored in a beam will be how much? We indicate strain energy with U, and total energy strain stored will be U of AB, strain energy stored in AB beam plus BC beam. Okay, so this I have given a total strain energy will be equal to UAB plus UBC. Now U is equal to how much? Integration of m square dx upon 2EI. This is the formula for U. If we take it from zeros to L, from whatever quantity we take. Okay, so we take this from, this expression is for UAB, that is the strain energy which is stored in the beam AB, and this expression is for the strain energy which is stored in the beam BC. So this is UBC. So if we take a moment at in UAB, what we get is, we get RA, we already got minus W by 2. So if we take at the distance X from here, we take moment here over here, so it will be how much? W minus W by 2 into X whole square upon 2EI. This is all given in formula, so I have replaced M by minus W into X by 2. Okay, and from 0, and from how much will we integrate? 0 to L. So we have integrated from 0 to L. So we find out from this equation the amount of strain energy stored in AB beam. And here also we take from 0, from this point to L by 2, since distance is L by 2, we take integrated from 0 to L by 2, and then we take the value of moment M is equal to minus WX. Why? Because this W load is acting, we take this load, this into distance at any distance X. Let's suppose this distance be X at distance X from C. So moment at here will be W into X. So we take it as W minus W into X upon 2EI. Okay. So total strain energy U, after solving this equation, we will get as W square LQ upon 16 EI. Okay. Then according to Castigliano's theorem, deflection at any point is equal to the differentiation of strain energy with respect to load W. Okay, so deflection at C will be how much? Differentiation of strain energy du upon dW. If we differentiate this equation by dW, we get 2WLQ upon 16 EI. So this will be represented as 2 cancel. So this can be written as WLQ upon 8 EI. So this gives you the value of delta C. Okay, so the correct answer for this will be delta C, WLQ upon 8 EI. That is, B will be the right answer for this equation. Okay, so let's move on to the next question. You can take the screenshot of this answer. Okay, but please try to not to take the screenshot just before I've started writing. Okay. So then let's see the next question. The number of independent equations to be satisfied for static equilibrium of a plane structure is. Number of static equilibrium, we know what were they? Sum of fx is equal to 0, that is forces acting in x direction is equal to 0. Okay, then forces acting in y direction is equal to, so sum of forces in y direction is equal to 0, and then the moment, sum of movement at z direction is equal to 0. Suppose this is the z direction, this is x, this is y, and movement acting in z direction is 0. So these three equations indicate the static equilibrium. So the number of independent equations which are used to satisfy for static equilibrium of plane structure is 3. So C is the right answer for this equation. Okay, here I have written the explanation, you can go through it. The number of independent equations to be satisfied for static equilibrium of plane structure are 3, that is sum of Fx, forces acting in x direction, forces acting in y direction, and moment acting in z direction is equal to 0. Okay, so let's move on to the next question. These are very small and important questions which UPPSC all asks. Okay, when I qualified this exam, and these were the level of this exam, and I was also shocked at how easy it was, but it was not easy. You have to find out and you have to solve the question. So don't think that the questions are very much easy, and easy questions will come this time also, because this time syllabus and you can say the pattern has changed, and a lot more. The new questions might be there or might not be there, but still you have to practice these questions. These are very much important for your exam. Okay, so start solve with me. Then see the next question. The degree of static indeterminacy of a rigid jointed space frame is. Degree of static indeterminacy of a rigid jointed space frame. It is given in space frame. Okay, so space, whenever space frame comes, then you should recognize it as a 3D frame. 3D frame, that is 2D frames are normally like this. This I can show you. These are the 2D frames, and 3D frames you can see them act like this. These are the 3D frames which you can see. These all end are fixed, and this you can also say this frame or this frame you can say. Okay, you can connect these and these and these and these. So this frame you can say that this is a 3D frame and this is the 2D frame. So this represents the space frame. So we have to find out the degree of static indeterminacy of a rigid jointed space frame, where M, R and J have their usual meanings. M stands for member, R stands for reaction, and J stands for joint. So first let's see what is degree of static indeterminacy. Degree of static indeterminacy is indicated by term ds, and it is equal to the total number of unknown reactions in a structure minus total number of equations available for equilibrium. Okay, then we should see that in a rigid frame, each member has 6 internal reactions, and what are they? Sum of Fx, Fy, Fz, Mx, My and Mz. Okay, suppose this is a structure and these are its members. So each and every member will have 6 internal reactions. Okay, and these internal reactions will what will be say? Fx, Fy, Fz and Mx, My and Mz. I have already mentioned over here. Hence total reaction in total internal reactions in the member. Suppose total internal reaction in this member will be how much? Suppose this is the number of members. Number of members, let it be M, and each member have 6 internal reactions. So into 6. So 6M will be the total number of internal reactions. So 6M, total internal reactions come 6M, and at each joint there are 6 equations of equilibrium available. That is in a 3D figure, that is in a space frame. In a space frame there are 6 equations at each joint. There are 6 equations of equilibrium available with us, and that is sum of Fx is equal to 0, sum of Fy, sum of Fz, and sum of moment at x, sum of moment at y, and sum of moment at z is equal to 0. Hence, total number of equations of equilibrium is equal to 6j. So how many joints are there? 1, 2, 3, 4, 5, 6, 7, 8. These are all the joints. So total number of joints is j. So total number of equations available for equilibrium 6 into j. Now the total number of data of static indeterminacy says is equal to total number of unknown reactions. Total number of unknown reactions are the sum of internal reactions, that is 6m. Total internal reaction plus total reactions on this in the structure minus 6 into j. J is what? Joint. 6. This will represent total number of equations of equilibrium. Then the formula will be 6m plus r minus 6j. So the correct answer for the space frame will be 6m plus r minus 6j. That is answer D is the right answer for this equation. Okay. So let's move on to the next question. A two-hinged semicircular arch of radius r carries a concentrated load W at its ground. Suppose this is a 2D figure and it carries a concentrated load W at its ground. This is the ground and this is the 2D figure, you can say, or 2D arch, you can say. The horizontal, we have to find out the horizontal thrust, that is H, acting on this structure. So this is a two-hinge arch, two-hinge, that is it is hinged from here and here, and it is not hinged from here. And this point, the topmost point, is called as a crown of the two-hinge or three-hinged arch. Okay, so we have to find out this H. We know that for a two-hinged arch with a load acting as W at any section, the radius vector will be at an angle will be H is equal to W sine square theta upon pi. Okay, that is the horizontal reaction will be like W into sine square theta upon pi. That is this W acting on any side of on any part of this two-hinge arch and making an angle theta with the center. So that horizontal reaction produced by it will be W upon pi sine square theta. And the question they have given that this load is acting at the crown, that is at crown is this point is the crown. So crown is at how much angle? That is 90-degree angle. So if we replace theta over here with 90 degree, we get H is equal to W upon pi. Okay, so correct answer for this equation will be W upon pi. That is B is the right answer for this equation. In this you have to write down this this formula. This is very much important for your examination point of view, and if you learn this formula then you can directly solve the question without any problem. Okay, so just learn it for two-hinge figure. Then comes the next question. Please neglect this question number. The horizontal thrust at a point support A in a three-hinged arch shown in given figure is, that is we have to find out the horizontal thrust H acting in this three-hinged arch. In the previous question we have seen that was a two-hinged arch, but here it is a three-hinged arch A, C and B. So firstly, this arch is given. This height is about 5 meter. This is 20 meter, and this load is acting on the left span. That is 2 kilonewton per meter of load is acting on it. We have to find out the horizontal thrust H. So how we will find out? Firstly, we take the we find out the vertical reactions RA and RB at point A and B. So for this reaction, we need to say sum of vertical forces equal to 0. That is sum of forces acting in y direction is equal to 0. So RA plus RB is equal to 2 into 10. How much the load will be? This total load will be how much? 2 into 10. Okay, 10 is what? The distance. This distance is 10. And for calculating the UDL, total load of UDL, we multiplied by distance, and that is given 2 kilonewton per meter. So 2 into 10 is 20. So 2 is equal to 2 into 20. Sum of horizontal vertical forces are RA plus RB, upward force, and downward force is 2 kilonewton per meter. That is 2 into 20, 2 into 10. So it comes 20. So RA plus RB will be equal to 20. Then we take if we now we have to find out the reactions. RB, suppose if we take sum of moment at B, as it is a hinge, we can take moment at B equal to 0. So RA into 10, RA into 20, this distance is at 20 meter, then minus, because this will rotate the beam over here in clockwise direction, and this loading will rotate the beam over in here this direction, that is anti-clockwise direction. So it will be minus 2 into 10. 2 into 10 is the total load, plus this will be acting in the midpoint, that is at a distance 5 meter from here, and this 5 plus this 10 meter will give you how much? 15. 5. Okay, this 10 plus this 5. Okay, so it will give you this. So we get the value of R is equals to 15 kilonewton and RB is equal to 5 kilonewton. Okay, guys. Okay, so this RA will be how much? If we multiply this 2 into 10 and then we take it by equating it to 0, we get this will be 5 plus sorry, this written is wrong. This distance will be 10, 20 divided by 2, 10, and this is 5. So 2 into 10 into 5 plus 15. Okay, into not this will be 10. 10 plus 5 will be how much? This. Okay, so 10 plus 5 equals to 15. 15 into 10, 150. 150 into 2, 300. So 300 divided by 20 will give you 15 kilonewton. So this answer will be 15 kilonewton. So just in space of 15, you just put it as 10. Okay, so this value will be 5 plus 10. Sorry for this mistake. And then RA we have find out 15 kilonewton, and this RB will be equal to 5 kilonewton. And from this if we can take from calculate from this equation, if we subtract 15 from 20, we get 5 kilonewton. Okay, then we take moment at C is equal to 0 from left. Now if we take moment at C from left direction is equal to 0, that is from this side. Okay, then what it will come? RA into 10, this RA multiplied by 10 minus HA, this distance is vertical distance how much? 5 meter, minus HA into 5, then minus 2 into 10 into 5, because this 2 into 10 is the total load and it will be acting at a distance 5 meter. So 2 into 10 into 5 equating to 0. When we solve these values, we get the value of HA as 10 kilonewton. Okay, we put the value of equate value of RA from here, that is 15 into 10 minus HA into 5 is equal to 0. We take this value above this side, equal to 100 to 10 20 and 20 into 500. So 150 minus 100 is equal to 5 HA. So HA will be 50 over 5, that is 10 kilonewton. Okay, so the answer will be value is 10 kilonewton. So correct answer for this equation is B is the right answer for this equation. Okay, then comes the next question on the next slide. The effect of sinking of support by delta is to create a bending moment is equal to how much? We have to find out that if there is a sinking of support is what? If the support is here, after sinking the support settles down and the support settles down like this. So this will be delta and this will be the sinking of support. Okay, now for this sinking of support, the bending moment developed will be how much? Let's see. If settlement of support is clockwise, this is the clockwise direction, then the fixed end moment will be developed and it will be in anti-clockwise direction. This is the fixed end moment developed and this is the moment developed in a member. Okay, and if this is clockwise direction, then the fixed end moment will be in the anti-clockwise direction. So this is the support gets settled by delta and it will create a sinking moment of fixed moment of 6 EI delta upon L square, and this is the answer. This is very important question. They usually ask in many of the exams, so just mark it up that MBA is equal to, due to effect of sinking, it will be 6 EI delta upon L square. Okay, so answer will be 6 EI delta upon L square. Okay, So let's see the next question. Which one of the following pair is correctly not uh, correctly matched? Both ends pinned. When the both ends are pinned, okay, then the L effective length remains the same, that is L. So buckling load formula for buckling load is what? N square pi square EI upon L square, L effective, okay. So when both ends pinned, then L effective remains the same, L square, then hence this is right. When both ends are fixed, when the both ends of column are fixed, then L effective becomes twice of L. So if we take L square, replace L square by 2L, then it will become 4L square. Then hence both end fixed, it will come as n square pi square upon ei L square. So L effective will be replaced by 2L. So it will come as 4 pi square. 4 will become, this will come as n square pi square ei upon 4L square. Okay. And then one end fixed and other end free, it will be 0.25, and one end fixed and one end free. When one end is fixed and other end is free, then the value of L effective becomes as 2L. And yes, when the both ends are fixed, this value not becomes 2L, it becomes L by 2. Okay, when both ends are fixed, L effective becomes L by 2. So if we replace this L by 2, then it will come L by 2, then 4 will come upwards. Okay, so this will be 4n square pi square ei upon L square. Hence the for both end fixed, value will be 4 pi square ei upon L square. So this is also correct. Then for the third point, one end is fixed and one end is free. That is, for one end fixed and one end free, then the value of L effective will be twice of L. So twice of L, so it will be 1 upon 4. 12 L square will be 2L. When we whole square it, then it will come 4L square. So 1 upon 4 will be 0.25. So this is also correct. The A is also correct, B is also correct, and C is also correct. So we have to find out which is not correct. And then the one end fixed and one end pinned. When one end is fixed and other end is pinned, then the value becomes L by root 2. Okay. So L by root 2, when this value becomes L by root 2 for one end fixed and other end hinged, then user's buckling load becomes pi square ei upon L square, so it will become 2 pi square upon ei upon L. Okay, so the value will be this. No, this is the wrong. So this is the wrong answer. So this is not correct. It will not be under root. It will not be under root. It will be 2 pi square ei upon L. So this is the right answer for this equation. So I will discuss, because of this confusion, I will discuss once again that when the both ends are fixed, then the L effective length of this column will be L by 2. Okay, and when one end is fixed and other end is hinged, then the effective length of column will become L by root 2. And when both the ends are pinned, then L effective becomes equal to L. And when one end is fixed and other end is free, then in this case L effective becomes twice of L. Okay, these are the 4 conditions. You can take the screenshot of this and learn it. Very much important. This is very much important for every exam. Okay, so that is why I have taken it again, because of the confusion in previous slides. So I have taken it over here again, and you should write it down. Okay. Then comes the next question. A rectangular beam of width 200 mm and the depth 300 mm is subjected to a shear force of 200 kN. The maximum shear stress produced in the beam is, we have to find out the maximum shear stress produced. So shear force is given as 200 kN. This is a cross section of the beam. So maximum shear stress was given by Vu upon BD gives the maximum average shear stress. So if we replace VU, that is 200 into 10 power 3 upon BD, BD is 200, 300 into 200. So if we cancel it out, it will come 1000 upon 300. We cancel this 10 by 3. Hence, tau maximum, this formula is very much important. Tau maximum is equal to 3 by 2 of tau average. Okay, so this is the correct answer for. So this is the very much important formula. So you should remember this. Okay, this directly comes to solve in the exam. So by tau maximum will be 3 by 2 tau average. So tau, this was the tau average. When we replace this value over here, we get 5 Newton per mm square. So correct answer will be 5 Newton per mm square. Okay. So let's see the next question. The degree of kinematic indeterminacy of a frame is shown in the figure. Ignoring the axial deformation is given by. Now we have to find out the kinematic indeterminacy. Kinematic indeterminacy indicates the degree of freedom. Indicates the degree of freedom of the structure. I will make a lecture on this static and kinematic indeterminacy, in which it will be cleared. Okay, for each and small end point I will cover up over there. Here you can just see that dk is degree of static indeterminacy, and for this structure it is given by 3j minus re minus m double dash, where j is the joint, re is the external support reactions, and m dash is the axially rigid members which are there. So it has mentioned that ignoring the axial deformation, we don't have to take the axial deformation. Okay, so these are the axially rigid members. So axially rigid members are how much? 1, 2, 3, 4, 5, 6. So 6 are the members axially rigid, and number of external supports reactions are, suppose these two are hinged, so 1, 2, 3, 4, R is equal to 4, and joints are 1, 2, 3, 4, 5, 6 number of joints. So if we replace the value of this in the above equation, we get it dk as 8. So correct answer for this will be 8 is the right answer for this equation. So thank you guys for watching my video, and this was the last question. And if you please if you like the video, then please like, subscribe and share my channel with everyone, so that you all get to know the last year questions which have come in the exam. We will be taking up questions from 2003 to 2013. Okay, all these questions we will be solving over here, and I hope I will be covering up structural part, and Rupali Gupta ma'am will be covering environmental and many more subjects she will also take. So do watch her videos also, and if you need any other thing regarding the material for UPPSC assistant engineer examination, then you can comment in the comment box provided below. Okay guys, okay, thanks a lot for watching my video.